Alright, so this is the balancing practice, extra practice sheet we got today, Wednesday. I'm going to start with number 3. It's a relatively simple one. First of all, we start counting the atoms on both sides. So let's start with silver, which is Ag. And this is number 3. Silver has 2 next to it, so there's 2 silver atoms on the reactant side. On the product side, there's only 1, so we add 1. Now they're equal. Now we look to oxygen, there's only 1 on the reactant side, and there's 2 on the product side. So we need to add 1 over here, but we cannot just add oxygen, we need to add the entire molecule. So Ag2O, need to add. So now there's 2 oxygen on the reactant side, 2 oxygen on the product side, but we affected the silver amount. So now there's 4 total silver Ag atoms on the reactant side, and there's 2 on the product side. So what do we need to do? Add 2 more silver over here, so to balance those out. There's 4 on the product side and 4 on the reactant side now. Now it's balanced. The last thing we do, the last step, is putting in the coefficients. So here, there are 2 molecules of Ag2O. So there goes a 2 there. This has nothing to do with the subscripts, only the molecules. There's 2 molecules. Then we move over here, 1, 2, 3, 4. And oxygen, there's only 1 molecule. There are 2 oxygen atoms, but there's only 1 molecule. I'm going to do one more. Let's start with number 5. Count atoms on both sides. There are 1 potassium over here, 1 potassium on the product side. And 1 magnesium over here, 1 magnesium on the product side. Now 2 BRs, 2 bromine atoms, 1 bromine. So I need to add a bromine, but I need to add a KBr. That affects the amount of potassium, so I go back over here, I have to add another potassium. Now it's balanced. Now we add the coefficients, 2, 1, 2, 1. 2 atoms there, 1 molecule there, 2 molecules of KBr there, and 1 atom of magnesium. Let's do the reaction types for both. For 3 is a 1 whole compound breaking up into 2 separate. So that is a decomposition. So 3 is a decomposition reaction. Decomposition. Then we go to 5. This is potassium switching spots with magnesium. So there's a single atom, and then at the end there's also a single. So that's why it's a single replacement. And that is how you do those 2. Those are relatively simple.